Adarsham Panigrai from Student Placement Council, and welcome to this industry interaction cell conducted a data engineering session. So today we are honored to have with us Mr. Prashant Ashwath Ram. He's a visionary leader in analytics and cloud technologies, and is also currently the Vice President of Technology at KPI Partners. So I would like to now hand over the floor to Mr. Prashant and continue the session.
All right. Thank you, Adarsham, and thank you all for joining in and for the interest shown, and thank you for the platform. So today's session, we want to briefly cover, how the industry is heading towards with respect to data engineering. What are the most common aspects of data engineering? And before I get into all of that, let me quickly give a brief introduction, right? So Prashant Ashwatram, so proud to represent our organization, KPI Partners. So I have about 18 plus years of experience in this domain of data engineering, data analytics, data space, essentially. So I've worked in product companies and consulting firms. So been here doing a long time on the data side, and it's probably one of the most exciting times to be in this space of data world. And I'm sure all of you guys are, excited to kind of venture into this world. And I'm sure you're interested to see what I have to say. So let's briefly jump onto it. I don't want to, we have very few slides, and I want this to be an interactive session as well. Especially, I would like to kind of share our insights and how, we operate, what are the key trends, and, what are the different opportunities that you can have in this field of data. And I'd be glad to answer any questions that you may have. Okay, and let's get into the next slide. So, and let me, start off by saying that, not much have changed with respect to what businesses want, right? Been here with over 2 decades doing this thing, right? So back in the day, this is back now, right? Data has always been like the most critical aspect for a successful execution of business, right? As the adage goes, the old adage, data is the new oil. It is continues to be the new oil. But what has changed from back then to now, right? So when I started my career, data was, still the unexplored or unutilized, resource, and data warehousing was really coming up to speed, and it was booming, right? This was, I'm talking about early 2000s. And right now, almost 2 decades later, data is still perceived as the most valued asset for any company, right? Because the world has evolved, there's a lot of digital footprint, which means there's more emphasis on the importance of data and what you can derive from this data, right? So there's more and more data being generated, but the purpose was always been the same, right? How does this data help the businesses to grow? How can they get the most out of this data, right? And right now, the only difference from back then to now is, the data has grown multifold, right? Tremendous, multifold of the data. Now, processing all of that data and delivering value to business on time is where data engineering plays a very, very crucial role. And we have been day in, day out dealing with conglomerates which deal with terabyte scale data on daily volumes, right? And crunching that volumes of data and really getting the meaningful insights to business on time that can turn into business value and additional business is the key. That's the most critical aspect, and that's where data engineering becomes the most sought after and lucrative field for us. Okay, so let's go to the next slide. So yeah, so how does a data driven organization derive value, right? Again, same thing, right? Typically, right from back in the old days to now, right? You are bringing in all of this data, and then you are then doing some kind of data exploration, right? Analyzing this data, preparing this data, gain valuable insights, and you end of the day you have all the modeling things, and then you have eventually trying to do some kind of insights that can assist your business in value additions. But imagine the scale that now extraction of data, gone are the days where you may be just getting in the data At the end of the day, you process that data, then you kind of, you know, build some kind of semantic modeling around it, build some meaningful insights, build some KPIs, derive some KPIs, and then give it to the business the next day. Those days are gone, right? Because right now the data is being generated, every split second. And uh, to say that, the point in time data set and point in time analytics is what really many organizations are looking for, right? So you don't have that delays anymore. And the volume of data that's being generated is also equally increasing. So the speed and scale at which you have to operate, you have to fine tune your data engineering um, platforms is really to the nth degree of complexity now, right? Because we are dealing with batch models, we are dealing with streaming data sets, we are dealing with different kinds of where value, veracity, and volumes of data. Having the ability to scale your platform to meet those spikes is what basically becomes the most challenging aspect and most interesting aspect. And there's been a lot of developments in this space as well, and I'm sure all of you guys have been following the new developments and improvements in the space, new tools and new age cloud platforms that have been kind of really leading the markets now, right? And we can briefly talk about that as well in the upcoming slides on where we see it, what are the key skills that you would need. But that's where the data engineering space really has taken multiple steps of leap. And there's huge demand in that space because of the complexity and scale, and then we will need to support that for the industry. Then comes your data science aspect, and there's been a lot of strides, a lot of advancements in this, a lot of automation, to say the least, right? And I'm sure all of you guys have been up to date with the LLMs and all these automated data models, or large language models, small language models. So there are plenty of models out there that have come to the forefront. But for all of that abilities, all of that capabilities for organizations to be able to do that, the key thing always remains the data engineering portion of it, right? You still need a solid data platform, a solid data engineering principles, and solid data engineering foundation to be able to make the most out of the data that gets generated. And that's where the key thing is. Every organization is investing heavily in building best data practices and building a platform, or what to say, data enterprise platform that allows them to do data science and analytics. Let's go to the next slide. So typically, what are the roles, right? So I mean, data engineers and architects, I mean, these are just common jargons that you're looking at. But what I would like to kind of highlight is for people to understand this: data engineers and data analysts are kind of the building blocks, right, for your data engineering organizations. But what this data engineer has to do is kind of changed over time, right? Back in the days, you have typical simple traditional ETL tools that a data engineer can learn, and that would be kind of the enterprise platform that you use to build all of your data pipelines. And the data analyst may be just dealing with few data sources and understanding how to analyze this data and build some reports or use some data visualization tools. But that's not the case anymore. With the expansion of the footprint of all the different data tools, a data engineer now has to be a lot more dynamic in nature, right? So at the forefront, you have all these open source technologies that have gone leaps and bounds, right? So you pick platforms like Databricks or Snowflake, or even Hadoop and big data ecosystems, which started the origin of this, new renaissance in the data handling capabilities. And now you have this Databricks and Spark-based ecosystems, which means the data engineer has to constantly evolve and learn. And even to this day, there's new enhancements or new developments coming up in this data engineering space that, data engineer will basically be the forefront person who will be adapting these new technologies to handle the gazillion amounts of data that gets generated. And then the data architect role is also equally crucial because of the way the data platforms are set up, and you have n number of different ways that you could design your solution, right? So with all the open source advents, you could choose it to be all on-prem or all cloud, hybrid cloud. Customers have become even more receptive to completely running their operations off of cloud, right? So we have done a lot of complete modernization engagements with our customers, even banking and finance customers who are now open to move completely into cloud ecosystems, right? So the trust in this cloud platforms and cloud native and cloud ready solutions are growing in the market, and people are adapting to this complete cloud ecosystems. Now, but what that also means is that now people are looking for a more open and diverse platform, right? You don't want to get logged into any proprietary format. And that's where this open source has led to huge list of choices, right? So for a data engineer or for a company right now, there are a lot of options. Back in the days, there were very few players that used to give you products that you can use to build your data platforms on. But now, it's spoiled for choices, but that also gives a bigger challenge. Do you want to get logged into a single vendor or a multiple vendor? And what the industry is leaning towards is people are looking for a best of breed architecture, right? What does best of breed architecture mean? It means you are going to be utilizing something that's the best in data integrations, right? So you want to use Spark, you want to use, Databricks for all of your data engineering work. Fine, because that's kind of your market leader now in doing all these Spark optimizations. But now when it comes to visualizations, Databricks may not be as good, or how people consume the data, there may be a data visualization tool that people want to adapt. And for data science, you may want to use something completely different platforms, not necessarily stick to this one single platform, right? But that is feasible now with the way everything is kind of more looking towards interoperability, right? Now, just for an example now, you look at simple file formats, right? So if you're building a data lake, and you could choose to use any kind of file formats you want, but even in that, you have different choices. You could use Iceberg, you could use Delta file format, or you could use Apache Hudi, right? All of these open source platforms are proprietary formats which are now open sourced. And the reason is because this interoperability is going to play a big role with the way every organization is trying to make their platform more open so that customers can adopt the technology. And that's where the data architect's role becomes a very crucial one. And that role basically defines the roadmap and strategy and how you'll have to build your enterprise data path and organization. And we help a lot of our companies or clients to basically build a strategy roadmap and design this. And that's where the data architect plays a very crucial role. And the database administrator is I would say, a deprecated term, to say the least, right now, because the data platforms are so much more dynamic that you're really looking at somebody who's an infra specialist, right? It's like really going to be a very cloud infra specialist, somebody who can help scale the platforms to handle the incoming loads, right? So that role is also going to be a very sought after role. And then data visualizations, back in the days, a single tool, or you just learn, be a tool jockey, that would suffice. But right now, tools are getting smarter, right? So you have tools that you just feed in the data, and this data visualization tool can give you the insights that you would take 10 minutes to figure it out, right? There's so much AI built into these tools that a simple knowledge on tool is not going to be sufficient, right? A data visualization specialist more so has to be a combination of a data analyst, somebody who understands business, somebody who understands the business outcomes. They can be more successful, data visualization specialists. So the roles are actually evolving. So what we try to put here is yesteryear roles and then how these roles are evolving over time, so that the expectation from these roles are only going more and more, right? So you have to keep constantly upskilling yourself to be able to keep ahead of the curve. So these are the typical roles. Now let's get to the next slide. And since the focus is on the data engineering side, let's look at that, right? What does this person typically do? And right, so far we have been talking about all the different stages, right? But the key aspects again is that now all the organizations are looking at building a, a data silo, right? So, but this data silo cannot be, an inoperable silo. So think of, the transition of the industry is more towards ability to build lake houses, or a single lake house if possible, or there will be multiple lake houses, because obviously each organization will have multiple different data generators, right? So you have data sources, a lot of different kind of data. So every aspect of a business now is digitized, right? So you will have a lot of data feeds, and building an enterprise data lake house is kind of the holy grail. But people don't get there in a single step, right? So companies really end up building multiple data platforms. And then what's really taking shape now is the most upcoming, or I wouldn't say it's upcoming, it's already been there and many companies have successfully adapted it, is more of a data mesh or a data fabric architecture, right? So because there's all this huge data sets, terabytes and petabytes of data sitting around, and you still need to tie all this together. So you kind of build a data mesh architecture. And for all of this, the starting point is basically the ingestion, right? Getting this data from multitude of different data sources, building resilient and robust data pipelines that are fault tested, right? They cannot really, you have to build them for fault readiness, right? If something fails, the data pipeline should be resilient enough to kick it off from the point of failure, right? So we have all of these different pipelines that have been developed for data ingestion. And then you have this data transformations, and then storage, as I said, again, right? The cloud storage, on-premise storage. Right now, with all the different platforms and solutions and advent that's been made, doesn't really matter where your storage is, right? So we have uh, customers who kind of embrace all these different hyperscalers, the cloud hyperscalers. You might see one division of a business maintaining their lake on AWS, and then there is another business division that's maintaining it in Azure. But guess what? This is no longer a problem, right? People can still, with the help of these open source technologies or building an open architecture, right? The storage doesn't matter whether it's an AWS or Azure or GCP or any other cloud for that matter, right? There is a holistic view of tying all of these data sets together, processing all of this. So the concept of data virtualization is also, very heavily sought after. Now, all of these aspects, what I just said, is not going to be a simple task, right? It's going to be complex. And guess who does all of these roles? So data engineering is this one discipline within any organization that's responsible for building this entire ecosystem, right? Anything that can happen after this, like building your data science insights or anything of that matter, you cannot proceed unless you have a really solid data foundation, a data that the organization can trust to use and invest more time to gain insights from that data set. So that's where the data engineer's role is very, very critical in, building the roadmap for a data-driven organization. All right. Next slide, Adasham. So now we were talking about all this data engineering, and I wanted to kind of give you guys or share some of the uh, examples, right, where we have, successfully created uh, an impact, a positive impact on the business, and how they were able to kind of, move from there, right? So let's first take the supply chain and manufacturing, right? Very common use case, right? Where, obviously at this right now, there's manufacturing 4.0, right? So all the companies want to build automation. All the organizations are looking at optimizing their manufacturing life cycle, right? So which means that you have to make sure that all of these manufacturing devices, equipments talk to each other, right? So it's not just about this olden age where you have different manufacturing units and they're just operating and you have physical maintenance. Now everything is digitized. You have sensors, you have telemetry data coming out from all of these different manufacturing equipments that you can do preventive and predictive maintenances as well, right? So one such example for us was that we one of an FMCG company, right, of ours, where they were actually wanting to make sure that and these are one of the largest FMCG producers who are based in US and Australia, right? Now their manufacturing scale is so large that any impact to any of their devices or any of their manufacturing equipments would actually result in millions of dollars of loss, right? Because their pipeline, because it's FMCG goods and you cannot delay, the delivery of these goods to the shelves of the supermarkets on time, that any delay here would definitely result in millions of dollars of losses. And they cannot afford to have any downtime with their manufacturing plants. So the key thing here is that they have to constantly monitor and build some, preventive maintenance. And, the biggest challenge there was fetching all of this information across all of the different um, manufacturing centers. And they used to have different systems called, there is MES systems, what we call it is manufacturing execution systems, right? Sometimes these are centralized, sometimes these are specific to a particular kind of manufacturing equipments, right? Now, these MES systems gather all this telemetry data, gather all the sensor information, right? But fetching this information is not just enough, right? Because these are again sitting in small data silos or data marts in each of these things. But to get a holistic view and then run your prediction algorithms and prediction models on this to ensure that if you are anticipating anything to go wrong, you should be able to take preventive action even before this incident can occur. And what we delivered to this customer is we built this data engineering team that was able to pull this information from all of this manufacturing equipment systems, pull that data into a common data lakehouse, and then this was all in real time, right? The data, the real time streaming data being fed into all of these systems, and the telemetry data and the sensor data was constantly monitored. It was put through a prediction model that would tell us if there is something likely to happen. So that and the success ratio was 90%, right? Which means there may be one in 10 times it may be a false alarm, right? But other than 9 times, they were able to basically make sure that the device did not run through any, challenges. So that's very key in manufacturing, right? And another use case that I want to briefly talk about where data engineering comes in very handy is, again, when it comes to supply chain and logistics, right? So the same manufacturing, the FMCG company supplies goods, but maintaining the logistical information is also equally important, right? So when you know that you are going to be delivering goods to almost, 8,000 stores across the country, it's not going to be a simple task, right? You really have to have a very complex, easily manageable logistics system, right? But a simple challenge of sometimes the and what I'm trying to tell you is one of the very small use cases where sometimes these logistics partners they might not be using the similar same vehicles. The tagging may not be appropriate. They might choose different vehicles at times, right? So because all these companies tie up with logistics partners, now there are scenarios where they were not able to track which lot ID or which goods are delivered to which centers. And so what they've done is they've created CVS use cases or computer vision, and to capture the number plates and driver images and stuff, right? So every time a truck leaves a warehouse, then you need to capture this information and you need to kind of maintain a repository so that in real time you can track whether this asset has reached there or not. All right, so we have designed this solution, and again, very simple use case, but then um, the challenge was that collecting this information across all the different warehouses, right? And you have these cameras that are set up, but they may not be able to get the tag ID appropriately. They may not be able to get the additional information correct. So that's where you can make improvements on your data engineering pipelines. And, so it was a collaborative effort, but then this data engineering team helped capture these images, help them enhance it, and then maintain this. Then grab the data from this image and then maintain a metadata or the entire history of all these logistical shipments, right? So different kinds of use cases, but guess what happened after this was that 99.9% of the times their logistics deliveries were successful, right? There were never any delays because once they started tracking this down to the lot level and the truck numbers, right? I think the compliance was reached for this customer and they were able to deliver goods on time. And if there were any delays, they were able to preempt it and they were able to route alternate trucks to reach that destination. Right. So that's where the business value is, right? So that you have the business goals met with the help of the data engineering practices. So another example that, typically where data engineering comes in, very important thing is, let's take telecom, for example, right? So you have something called enhanced customer experience. Now, all of us, obviously, now everyone here uses mobile devices, internet services, and all that, right? But imagine, or take Airtel, for example, right? Airtel or any of our providers, they don't offer you a single service, Geo, Airtel, or, Oda, Idea, if anybody is still using those platforms, right? So the thing is, you might have subscribed to multiple different subscriptions or multiple different products from this company, right? But right now, it is always a challenge when these things grow organically. Sometimes companies acquire companies, right? In this case, Vodafone and Idea. And same things happens a lot with many of our customers, where the company grows by acquisitions, or company grows independently as different units, and then they merge together. The biggest challenge there is giving a holistic experience and enhanced customer experience, right? Because the same subscriber in one service may not reflect the same subscriber in another service, right? And right now, all of these companies have implemented good practices, and now, this is not, if you see that as a problem, then obviously you'll be frustrated as a consumer, right? That's where the business value is, right? You want to make sure you understand who is this consumer and how can you give the best experience to the consumer. An internet subscriber, a TV or a set-top box subscriber, or a fiber optic subscriber, right? Or a mobile postpaid or a prepaid subscriber. They could all be different consumers, but trying to tie them to one single customer ID, right? So that's a challenging thing, especially when people use different names and data entry challenges. And that's where data engineering plays a very, very crucial role, right? So you try to bring in data across multitude of different systems, but you apply intelligence to make sure that you unify them. And there is this concept of master data management, right? Where there are different tools designed for these use cases that allows you to bring all of these data sets and help you identify which customer is it the same customer, is a different customer, right? So those cases, that is something that will have a huge profound impact on business, how well they can market to this customer, how can they improve the value of this customer, right? So how can they make the customer spend more, right? Obviously, if you're happy with the services, you would definitely recommend it to more people, obviously, right? So that's the kind of impact a solid data engineering practice in any organization can have. So this is not just from the end user perspective, even getting that holistic view of these customers to the decision makers within the organization is very crucial. And the data engineering practice allows you to handle all these tough challenges and helps you give a holistic, view of the data. All right, let's go to the next slide, Adershu. Okay, so there is a question about telecom point. Explain again, please. So what was the doubt? I mean, let's have an interactive thing. Can you come, Subrat Tiwari? Please go ahead. Which aspect was unclear?
Sir, I got confused after the point you said, like one customer can have like many services from one company, and if one company, if one company acquires the other, after that I got just confused. What were you saying?
Sure. So it's basically the ability for the company to identify it's the same customer, right? So let's say that you might have first purchased a postpaid connection, right? Or a prepaid connection.
Yes, yes.
After a few years, you go in and you purchase internet services from this company.
Yes,
right?
yes, yes.
Now your addresses might be different, right? You from when you initially purchase, you might still be continuing that service. It's the same customer, but the way these systems are designed, it may not be able to trace it together.
Yes, sir.
Right? That's a very big challenge that companies have.
Yes, yes.
Right. And
Yes.
that's it. Or if, let's say, the same customer, you might be a customer of a company A and also company B using a different service, they both acquire, but the company will not know this is the same customer. It still sees them as two different customers. So they may not be able to cross-sell or upsell services to you. But the ability for company to understand that this is the same customer is, revenue for them. I mean, untapped revenue for them,
Yes, obviously. Yes, sir.
right?
Okay, okay. Thank you.
All right. Any other questions? All right. So what kind of skills are needed today, right? So as I said, the space has been evolving at breakneck speed, right? So the data engineers of yesteryears to now, you know, because the way the tools have exploded, because the way the platforms are lot many options, and good thing, right? Because the scale at which these data is there today, you have platforms that can process petabyte scale of data, right? Few years back, this was unthinkable, right? You had traditional databases where you were constrained by the compute resources or the data storage resources. But now in a scalable environment and the decoupling of compute and storage, you have a lot of the amount of firepower that you have at your disposal to process huge volumes of data is, unbelievable to say the least, right? And in order for you to equip and train yourself, then you really need to have a whole bunch of skills, right? But the key things for you to start for any data engineer, I would say, are fundamentally you should be really, really strong in your, let's say, uh, SQLs, right? Even after all that is said and done, end of the day, you are still expected to bring the data in and compress or aggregate and try to derive insights, right? SQL is at the heart of everything, right? So SQL is number one skill, ability to, understand the data models, understand the relationship between the data, and allowing you to kind of uh, write the queries to get what you really want, right? That's the fundamental thing. But right after that comes your, ability to build data pipelines for large scale data, which means now Python is becoming more preferred languages, and then Spark is kind of the de facto data engineering platform. So PySpark or Scala, whatever that you can do, right? So but Spark is kind of the most sought after thing for a data engineer. You should have SQL and Spark, and Python is something that you probably have to learn. Right now Python is pretty much used everywhere, right? These are the three must-have skills. Beyond that, knowledge on the cloud platforms, because every organization is looking at modernization and moving to a more platform as a service, as opposed to managing their own in-house data centers. And that's a big shift in focus. All the customers, or I mean the industry, is going towards a more platform as a service. So which means knowing a cloud platform and knowing these languages are going to be very, very crucial. And Spark is at the forefront, and knowing SQL is very important. And dealing with, data and relationships. Those are the foundational skills. And then you can keep adding more and more layers of complexity to your knowledge of data engineering. All right, next slide. So as I know, over this session, we have been talking about some of these trends and what's really been happening. But, to kind of summarize it, right, how the industry is trending towards and what's been the most sought after. The key thing is the rise of data mesh and data fabric, right? So the data mesh architecture was something that was kind of more publicized like 6 to 7 years ago, right? And then this concept of lake houses and warehouses, combining them together. And that's where the data mesh really became a big thing. But right now it's kind of a de facto thing. If you are talking about a multinational conglomerate, then you can definitely say that the data would be petabyte scale without a doubt, right? Look at all the different data feeds that you have today, your social media data, all your back office ERP applications, CRM applications, your application integrations. See, the amount of data that gets generated is humongous, but all these companies are doing a good job getting all of that data in together. Then comes the daunting challenge of making sense of that data, right? But that can be done by building a solid foundation and architecture, and that's where the data mesh and data fabric is kind of really, going for a rise. And real-time and event-driven architectures. And gone are the days of batch processing, right? Now customers want to do Lambda architecture, ability to do real-time ingestion of data and event-driven data. Let's say an action from a customer, a post, or could automatically trigger a flow of events, right? So those kind of architectures are more and more common. So that's the other thing. And then integration of AI into data pipelines. That's huge actually right now. So with the advent of LLMs and even this data pipelines are becoming smarter. I mean, we did briefly cover about the visualization tools are already becoming smarter, and they're a step early. Right now, you have BI tools and visualization tools where you can just ask a question, which of my divisions are not doing well? It can give you a completely auto-generated insights, right? But its ability to build that model and reports is down to how you have built the semantic model, right? But at least you just ask a question, it can do that. But the data platforms are also not far behind, right? Now, if you look at platforms like Databricks, you could just ask it, give me a code snippet to do this. It can generate that just like that, right? So what's important is for data engineers to now, the AI is not a competition, but it's a very important tool for you to use it and leverage it, right? Else, you will be left behind. So these platforms are also embracing AI, but still you need to be smart enough to understand whether that generated code is accurate, right? And at the same time, how well you utilize this AI into your data pipeline. So almost all of the data platforms are embedding some AI into it, which makes the life of a data engineer easier, but it cannot replace a data engineer, right? So the intuitiveness and the ability to think on the feet and understand the right solution for a complex problem, AI cannot do that. But it can make the life of a data engineer much more easier, which is where you need to start thinking of how these AI tools can help in building this data pipelines, and platforms are already doing that for you on these things. And if any of you have been using GitHub also, right? So to submit your projects, there's a lot of AI embedded into these platforms too. I'm sure all of you guys would have tried that out. And then the other growing trend, cloud native engineering. As I said, companies are embracing the cloud right now, which means gone are the days where you have to think of building something for on-prem and then how would it react into cloud. Now the solutions are built cloud first. So it's important that the data engineers understand this cloud platforms and, learn to live with that reality. And the one thing that I did not cover in detail, but it's very, very crucial, again, is data governance and security, right? So one of the other challenges of building this data mesh and fabric is now you're bringing in a lot of data into a common platform, a lot of sensitive data, right? So these are not, you might be bringing in payroll data, you might be bringing in HR data, you might be bringing in some PII data, personally identifiable information, right? So one of the important aspect of data engineering is the data governance and security. Right now, the organizations have created new roles called CDOs, right? So CIO is the person who kind of governs all your, um, infra applications and systems, but chief data officer and chief security officer, CSO, CDSO, these roles are becoming more prominent because the data is your most crucial resource, but securing that data is equally important, right? So the data governance and security plays a very, very crucial role. Adding a layer of abstraction and security on your data platform is very critical, and that's another key what to say advanced level a data engineer can then scale into, taking into account governance and security. And that's where this data ops engineers are becoming more crucial. I think we have a slide that covers the different roles. But yeah, so the data governance is very, very crucial and an important aspect, which is now all the companies do consider this as they are building their data engineering platforms and pipelines. All right. Now, the kind of roles, as I said, so foundationally, if you're looking at foundational roles, yeah, data engineers, data analysts, cloud data engineers, right? Those foundational skills that I mentioned, plus learning cloud, those roles really gives you that foundational roles. But getting into the next level is kind of the data architect, where you kind of address the challenges and build a roadmap or design, devise, and choose the right platform for the data engineering problems at hand. And then the data ops engineer is somebody who just doesn't think of the data pipelines and security, also talks about how to handle them, how to secure them, right? All the way the data life cycle, not just building data pipelines, promoting those pipelines, securing those pipelines, ensuring that the end consumers receive those data sets in the right with the right privileges and permissions. That's your data ops engineers. And ML engineers are basically kind of overlaps between the data engineering roles and the data science roles, who can kind of bridge the gap between the two. Okay. So there is okay, there are some questions now. Let's look at that. Shubham Gatani. Can we have remote opportunities in data engineering role? Okay. So remote opportunities. And okay, let me be honest here, right? So I firmly believe, doesn't matter where the consultant works from, right? As long as they know what is expected of them and they can deliver that successfully. That being said, my thing is, for people who are fresh out of college, or they're kind of entering the corporate world, and they're still learning their ropes, I would very much recommend them to basically work under the tutelage of a mentor or a buddy in an ecosystem that can help them learn the ropes and build your foundation. That's the most crucial aspect of your career, that you're trying to learn things the right way. After that, once you know what's expected, I think, yes, the working remotely is not going to be a challenge. Those opportunities are there. But somebody who has been there, done that, or who has the ability to handle the demands of the role, I think can still do a remote opportunity. Okay. Or ops engineers like cybersecurity engineers. I would say yes. Cybersecurity is a different discipline that deals with different kind of expectation, right? Now, when we say ops engineer, it's some aspects of the cybersecurity engineers what they do, but with respect to data, right? So your cybersecurity engineers are more responsible for, network security or application security, application risks and exposure, right? So they're looking at it more holistically. But when it comes to data ops, you are looking at, so in your case, data is your product, right? For a data engineer, his data is his product. So then that data gets consumed not just within the organization. Sometimes this data could be shared with external users, consumers, and all that. So that's entire data life cycle, right? When I say data life cycle, from the time the data is generated, is prepared, it's processed, then it's then consumed, right? So it goes through this life cycle, and throughout that life cycle, you're building and you're thinking about how this data's life cycle ends until it hits the final consumers and to all the other downstream systems, right? And building pipelines and making sure that the security is covered at every layer. That's the role of a data ops engineer, more focused on the data. How can we search for job in these domains? Okay, so all the different platforms out there, right? The job search platforms. I think right now data engineering is one of the most hot areas in the market. I don't have to say that, right? So I think a proper study on the, I mean, depending on which industry or which kind of firm that you need to look for, you could make a focused search in that, and then you should be able to land a job. Because even in this data engineering, I said some of the examples that we spoke about in manufacturing, supply chain, and retail, but every sector has its own unique kind of needs, right? So everything is now, let's say if you take any healthcare, for example, right, there will be a lot of, when it comes to healthcare, you have HIPAA compliance, right? So you are dealing with data. Everything is very sensitive data, which means the encryption becomes a big thing. right? So then you have to do certain specializations, or how you design this architecture has to be compliant with all these other norms that are set up, right? HIPAA and HIDA in US and Europe, or SOX compliance for financial thing. So there, for each of these domains, there are different additional things, and all of this comes with experience working in these domains. Okay. Would like to know if a project focusing on data ingestion is better for getting hired. I'm thinking of using some local simulations. So Deepraj's question about project focusing on data ingestion part. See, it doesn't really matter. If I'm understanding this question, you're trying to mimic something with local simulations and trying to build an optimal ingestion pipeline, which is good, right? So you're trying to mimic a real world scenario, not just for data ingestion, for any of these scenarios. And anything that you can do that can mimic real life and gain yourself some experience will definitely help, right? So okay, which cloud platform would you suggest for freshers to learn, like Hopworks, Azure Databricks, AWS Glue, Lambda? Okay, so all the cloud platforms are doing really well, right? Right now, data engineering pipelines and platform, I mean, companies are adapting to all of this, right? But purely looking by the market share, you see AWS and Azure kind of have most of the market share, with GCP not really far behind, right? So those are the three areas. I would recommend you can get a primer on cloud platforms in general, not just focus on a limit, a single cloud, so that you generally have an understanding. But if you still have to pursue, Databricks actually is supported on all the major cloud platforms now, right? Azure, AWS, and even GCP, right? And Databricks is kind of very prominent and most widely used platform, I have to say. But once you learn Spark, doesn't matter whether it's Databricks or Glue, right? You should still be able to leverage your skills. So I would say get a cloud primer, pick up Spark, and once you know Spark, between Databricks or Glue, you should, the learning time, once you learn the foundation, it should not be more than 3 to 5 days. Okay. What do you expect from a fresher applying for data engineer position? I think this entire session, what I just told, so we want people to have those foundational skills. At least what I would expect is, learning, you can always learn. What's another key aspect is that you need to have the drive, right? You need to have the drive to solve the problem. You need to have the drive to learn. Even if you do not know answer to a solution, you should have the drive and commitment to figure out the solution and do it. That's important. And having these foundational skills will definitely go a long way.
So, on the topic of having the drive and problem solving skills, as a data engineer, have you ever experienced a problem which you must have expected it must be streamlined by now, or that problem or challenge must the scale of problem or challenge could have been reduced by now, but it's still a problem you experience in your day to day, like you face when you try to approach data engineering problems?
Um, Let me try to rephrase this question or state if I understand it. So are you asking me if there were any problems that you have seen that are still not resolved today, which are
Yeah,
open-ended?
yeah.
Okay. See, in all my years of experience, right? So as I said, at that point in time, there's always a problem that needs to be solved. Okay. So that's the nature, the very nature of the challenges that we see, right? So 20 years ago, you used to generate 100 GBs of data a day, but the platforms were not sufficient. We solved the problem. Now we have better platforms, we have better, ingestion mechanisms and all that. Fast forward to 20 plus years now, today, the amount of data that's getting generated is so huge, but the platforms, can it handle it? It can, but it would choke. So as the problems, I mean, we are constantly inventing too, right? This space has grown enormously, right? The storage has come cheap. The data platforms have become a lot more, advanced, a lot more, what is it, sophisticated, to say the least. But there's always, there's more coming your way, and you have to. So just take this LLM for example, right? So you have almost 6 billion parameters for an LLM model, but you're still not getting good results at times, right? You can still fine tune them. You can tune them to give better results. And that's still happening right now, right? All the zillions of data that's been fed to the LLM is still not sufficient, right? It still can be improved. There's always something you can improve with. There's always more to come. But that's the beauty of the field that we are in, that there's a lot of focus and emphasis on this, and it's evolving at great speeds. Okay, basic technologies, I think we covered that. What are the things the companies want from a fresher to get them well-paying job? I think we covered that as well. How to prepare entry-level jobs for coming forward. Or some entry-level data engineering projects. Yeah. So as people new to this industry, right? What's the best way that you can prepare? Here's my advice, right? So I'm glad that IITM has programs like this so that we can share our thoughts on how this industry is evolving, and this becomes a good, opportunity and window for you to learn and understand. Back in our days, these were harder to come by, right? So this sharing of knowledge and having this forum to discuss. So how can you prepare? Now I've given some examples, right? But in any of these, the industry really expects the juniors to have, so your curriculum, we did look at your curriculum, and cover some of all the key areas that we would look from a data engineer, right? So our expectation, the best preparation that you can do is, as I said, the SQL, the Python, some of the foundational cloud, platform knowledge. Those things you have to have, prepare on those areas. And if you can go and pursue and get some, hands-on work, I mean, because all of these cloud platforms also give free credits, right? You could go to Databricks Community Edition. You can get the complete platform for you to play around with. You can go subscribe for Azure and you get a $300 free credit, and you can just learn on the platform. So don't be shy. Go and try it out. Use the platform. Back in the days, all these enterprise products from different small group of companies used to control the entire data warehousing space. You're not able to get hands on these platforms or solutions or softwares, right? But now that's not the case. You have everything at your reach. I would recommend prepare by doing hands-on work. And there are websites like Leet and all where you can really go and solve the problems, right? So there are real life problems that you can go and try and solve them. Get yourself prepared. That will give you a flavor of what kind of challenges that you would face day in, day out in your job. That will prepare you well. Those would be my suggestions. Most general nature of data used in ETL pipeline, text data, image data from Sprage, RTOs in industry. It's basically everything. There's no thing as general, basically, right? So you kind of have to deal with all sorts of data. Mostly, structured and semi-structured predominantly. Unstructured or, multimedia data will also be coming in, but I wouldn't put what is general, right? You will end up working with all sort of data. All right, I think we're almost at the hour mark.
Yeah.
Very,
So
very
I think,
good
yeah, I
questions.
think we can conclude the session. Like, yeah, I would like to thank you, Mr. Prashant, for this like a very insightful session. Like as a data science student myself, this session gave me deep insights about engineering and its impact also. And I think I hope it also motivated my fellow audience members to look into and even pursue data engineering as a career option. So yeah, so thank you for this very insightful and deep session. Yeah.
Thank you again, Adarsham, for organizing this thing, and thank you, Swati, and thank you, team. All the very best, guys. Thank you.
Yeah.
Bye.
Thank you, Prashant. Thank you.
Yeah, I also would like to thank Industry Interaction Cell for conducting these sessions on regular basis. Yeah.
Thank you.